So what we're going to be talking about is when, where, and how to automate Android, and I would say more specifically, or actually less specifically, just software in general. So a lot of what I'm going to be talking about applies not just to mobile or Android, but to software testing in general. So first of all, who am I and why am I up here talking to you about testing? So about 8 years ago, I started working at Intel, and I was part of a team that was leading the design and development of a distributed automation framework that was used for testing all of Intel's wireless communications devices, from the hardware all the way to the software that the end user was interacting with. Through that time, we learned a lot about automated test strategies, what works, what doesn't, not just at Intel, but also at companies like Cisco and Sony, and so on. And we have now taken that knowledge and our learnings, and we're applying it to mobile technologies. About a year and a half, 2 years ago, we formed a company called AppThwack. And what we do is we make it really easy to test Android applications and iOS applications on real devices. I might talk a little bit more about that later, but I'm way more interested in telling you just about automation in general. So a little bit about the agenda. So first we're going to set the ground rules. What is automation? What are we talking about? What is testing specifically? Also, what is the problem? Why are we even talking about automation and testing? Why should you care? I think since everybody's here in this room, I think we're all going to agree on that one pretty quickly. And then the when, where, and how that we're talking about. So choosing our battles, what are we going to automate? Where, so what kind of best practices can we apply? The how, the tools and the frameworks, and then we'll finish up with some Q&A. So getting into testing. So what is testing? So we have an ever-expanding list of different types of tests. So testing is an industry in and of itself, and the people that do it, and I'm assuming some of the people in this room, are from QA teams, and so you're very familiar with these terms. I mean, we have certifications and so on. From a development standpoint, we might be familiar with a handful of these, but at the end of the day, what we're really interested in, and for the sake of the discussion today, we're going to distill it down to functional and non-functional. So functional tests are the things that we know our application should do based on specifications, right? We may not have formal specifications, but we have some idea, right? When a user clicks on this button, this menu displays. When they pinch and zoom this, or when they pinch this image, it actually zooms, those types of things. We also have non-functional. So non-functional tests are the things like how much battery is it drawing, how much network usage are we doing, and it can also go to just the look and feel and quality of the application in general. These are things that maybe the specifications don't cover, but we definitely want to test for them. So what is the problem that we're solving? So building things is hard. So from a development standpoint, software engineering is a fairly complex discipline. Right? And I think with the advent of mobile and ubiquitous computing, we have an ever-increasing complexity that we have to deal with. Not to mention the fact that we have tons and tons and tons of different target platforms. And it's not just screen sizes, it's different operating systems, different versions of the operating system, hardware specs, and so on. So it's a very complex environment, and oftentimes we're not just running an application on a single device. We are actually communicating between devices. We're talking to backend APIs that are not on the device itself, but remote. So there are all sorts of moving pieces and parts that we have to deal with. But why should you care? So today there are over 1 million apps in Google Play alone. That speaks nothing to the quality of all 1 million apps, but there are 1 million apps in the market. Now, after 2 crashes, about 84% of people will start looking somewhere else. So maybe you have the luxury of owning a specific niche, and you don't have to necessarily concern yourself with the statistic, but it's pretty damning. We have 1 million apps, 2 crashes, and somebody starts looking somewhere else for a replacement. So this means they uninstall your app, which sucks, right? But if they're really, really angry, they're going to leave a bad review. And this is way more damaging than anything else, right? And it's not just to your ego. It also puts it on the public record that this person was not happy with you, right? And sometimes they're fairly eloquent. This one, actually like to use the word lag droid, right? Which is interesting. So we have been here before, and this is the thing that I really want to drill home tonight. And if you take nothing else away, I would like you to just understand that it's not like testing for Android or testing for mobile is some new, requires a new paradigm shift in testing. If we go back about 10, 15, 20 years, and you look at people developing applications that had to deal with all of the different sound cards and all of the different video cards out there in desktop computers and then in laptops and so on, and those people are still dealing with that problem, although their tools and their strategies have matured over time. And the same will happen for mobile and for Android and for testing your applications. So hopefully we can learn something from what's already been done and apply it to what we're all up to in this room and not have to reinvent the wheel. I think that would be an incredible waste of time. So let's choose our battles. So first of all, before we start automating and testing, we should understand what it is that we're testing for and also why are we automating. So enter the empty suit, and I used to work at Intel, and there are a lot of smart people there, but there are certainly this type of person there as well. Save time, save money, shrink QA, automate everything. This is a really, really unhealthy way of looking at test automation. You're not going to automate everything. You don't have to automate everything. If you step back and you look at your application and you've not been testing to this point, it may look like a very, very daunting task, right? How am I ever going to get started? My application, my code base is huge. How am I going to automate all of this? But you don't really have to, because there are certain things that you probably do more often than not. So it's really important to be realistic. So the goals of automated testing are to increase the regularity of testing, right? So maybe now you're doing manual testing, or you have a team doing manual testing. The goal here is to make this repetitive and not require the resources that it requires today. It also frees up those resources who would typically be doing manual testing, which might be you as the developer, or it may be a team somewhere, and allows them to focus on other testing efforts. So we're not firing the QA team. We're simply taking the resources and we're putting them on something that's much more valuable to our company. The last piece is we're enabling previously impossible tests. So this is an important thing to consider when automating, is that the computer is really good at things that we are not. And so it allows us to do all sorts of things that manual testing could never accomplish. So how do we decide what to automate? There are a few questions that we can ask. So the first is, how often will I test this? If it's once per release, I don't think it should be your priority to automate. And this seems like common sense, but time and time again, you'll see people start from the very beginning and just go all the way through, and they make it a little bit of the way through automating their tests, and then they quit. Is this something a human is good at? So it's really important to recognize the differences between a machine and a person. What is a machine good at? A machine is really good at repetition, number crunching, basically things that to a human we think are really painful and mundane. A machine doesn't complain, right? At least yet. So the last piece that we'll talk about is how much effort will automation require? So maybe this is a task that you have to repeat over and over and over again, but automating it would require a huge, huge amount of effort, depending on the complexity of your application. So some examples of things that we can automate. So we can automate granular activities, and a lot of us in this room probably do this. These are things like unit tests, where we're testing very small pieces of functionality. It's a pretty obvious use of our resources to actually write automation for this. And luckily, Android comes with a pretty nice instrumentation library just for this purpose. Also automating repetitive tasks, like I mentioned. So these are things like update paths, navigation, so just simple flows through the application. If I click here, this happens. Those are really easy to assert. Those simple flows through the UI. And the last piece is performance. And this goes back to that thing where I mentioned things that are somewhat impossible for humans to do. And performance is one of those. Oftentimes you're dealing with enormous data sets. You have to crunch a lot of numbers. It takes a long time if you're going to stress test an application. So this is a perfect application for automation, and something that you would enable through automation. You wouldn't be taking something from a manual test team and automating it. Things that humans are good at, so manual tests. So these are things like user experience. And this is something a machine is simply not very good at, right? A machine is not going to tell you that it looks or feels right. A person will tell you that. And the last piece is new functionality. So you should not waste your time automating new features that you've just developed. And this is simply because there's way too much change going on, and automation really flourishes in areas where we have stability to work with. So we're not introducing complex changes, we're not reworking flows. We've actually established that, okay, this is the way it's going to be at least for a while. So our options for testing. So I just want to talk about when we automate, what are we going to use? Or actually, when we test, I'll talk a little bit about just testing in general and who will actually be doing the testing. So on the machine side of things, we have, for Android specifically, we have the JVM. So JVM is super fast, right? Because we're not dealing with the overhead of an actual device or emulated components of the device. It's unit tests only for the most part. And we're dealing with mocks. And mocks are super helpful. So for those, I don't know how technical the room is. Mocks basically allow us to simulate and code more complex external pieces of our application. So it might be some layer that normally would exist out in the cloud somewhere. It allows us to mock this so we're not actually inadvertently testing this component in the cloud. We're just testing our application. On the one hand, it's really good because it allows us to run really fast tests against it. On the other hand, it could be kind of bad because it's not testing the actual real-world functionality of our application. In addition to JVMs, we have the JVM, we have emulators. So in the emulator, it's cheap. I think everybody in this room has probably dealt with the emulator. It's cheap, as in free. We catch layout issues in it. We can actually catch layout issues outside of the emulator as well at this point. So using an emulator for that is sort of a waste of time. It allows us to simulate calls in SMS. So if you're using tools like DDMS, it's super helpful. You can mimic all of those things. Really close to development, this is actually super handy, right? You're not sending this to QA for them to figure out that these things don't work. You're doing it as a developer. On the downside, they are really, really slow. And things have happened to change that. So we have x86 optimized emulators and so on. But it's still, there's an additional overhead. And they give the illusion of a one-to-one mapping to a real device. So I say illusion because it's an emulator. And emulation is extremely complex. And so you're never going to emulate one-to-one an in-device. And even if you were to emulate the hardware, you're likely not emulating the software portion of it. So we're talking carrier modified OSs and firmware. The last target, real devices. So real devices are exactly what our end customers are using, what our end users are using. We can gather real-world performance data. So when we look at the battery metrics, it's actually what the battery metrics are. They're not some sort of estimate that we've gathered off of an emulator. And they're super fast, maybe not as fast as the JVM, but they're relatively fast. They're definitely faster than an emulator. On the downside, they are expensive. There are literally thousands of them out there. So we have to purchase them. And then not only do we purchase them, they either rot away in cupboards, which if you've been developing for any amount of time, you probably have cabinets full of these things, depending on the size of your company. And oftentimes they gather dust and they're not hooked up for automated testing and so on. So on the human side, so we have QA teams. And QA teams are awesome because they're professionals at what they do. They provide real feedback. So this is a real human element to this. It's not a machine asserting that something passed-failed. It's a human bringing this to your attention and able to walk you through it. They usually know the product, or actually they do know the product. That's their job. So when they're talking to you about issues they've found, they actually know that they are issues with the application. On the downside, I mean, it's expensive. We're talking about humans on the team testing the application. So it takes time and it takes a lot of money and resources. We have the crowd, which provides, again, real feedback, just like QA. They might know the product depending on who the crowd is in this case. They're usually expensive and they're slow. I mean, again, they're humans. And the last piece is end users. And I would just say, don't do this. This is not an option. Don't use your users as testers. So I want to talk a little bit about best practices. And so these best practices, this is the I believe, where in my talk. So when we're talking about automation and QA in general and testing, it's really important to look at dev and QA not as separate entities with a big wall between them. And this is because it's really important that trust exists in both directions. If you set up this hostile environment where QA is tasked with just destroying everything development does, it creates this animosity from the development side, right? And if the QA team is trying to explain to the developers what they think is wrong, it can aggravate the developers who actually wrote the code, and so on. So it's really important that these people, if they're not on the same team, they sort of exist on the same team, at least in their heads. And so the no barriers, it allows the QA team, when they're talking to developers, it might not just be that QA is testing. It could also mean that QA it's not just QA automating tests, but developers are writing automation. But perhaps they're writing automation in a tool set that QA either developed or QA selected with development's buy-in. So you have a shared tool set between the two. You have buy-in from both sides. So when QA finds an issue and they bring it to the developer's attention, they don't have to convince the developers that it's an issue in the first place, right? They've already established this amount of trust, and they're all working towards the same goal. Automation is a software project, and all too often, it's looked at like something somebody could crank out over the weekend, or it's something that you can take QA guys or QA girls and throw them into a room and say, okay, hey, we're going to automate this even though you have no coding experience. And it doesn't make any sense, but it happens time and time again. And so it's really important that you give it the resources that it deserves and you treat it how it should be treated. I would go so far as to say that automating an application is likely at least as complex as the application that's actually being tested underneath, right? If you were going to automate every single flow through an application, you're talking more code and more complex code than the application itself. So to treat it like anything but a software project is a mistake, and it's going to end in failure. Automation is a tool and not a solution. So don't walk into this thinking that you're going to automate tests, and by automating tests, we're not going to have bugs anymore, or bugs anymore in even the code that we're running the automation against, or that automation is going to solve some quality problem we all have. Automation is simply a tool in that effort, but it has to be used correctly, and it has to be used like a tool. So it will help you by providing you with information, but it will still be you that actually takes this and applies it in a way that makes it a solution. And I will admit that that doesn't sound entirely clear. So. But it's important that you don't come at this like, we're going to spend the next 6 months automating, and that's the goal, and then we're going to move on to something else, right? It's an ongoing thing. Automate with precision. So again, we're not automating every single thing. We need to ask those questions I went over earlier. So we're going to ask, okay, how often are we actually doing this activity? How much time are we wasting on it? How hard is it going to be to automate? And then we will automate it, right? And as you continue on through automation and you're building up this code base, you'll automate more and more and more, but it's very important that you start off and you're really surgical about it. Because again, if you start out and you're saying you're going to automate everything, you're setting yourself up for failure. It's an unrealistic expectation. It's all about data. And when I say it's all about data, what I mean is that with automation and testing, it's important that you look at it. One of the strengths of automation is that you can actually data drive your automated tests. So if you are if you're testing manually, the amount of testing you can do is limited to your amount of time, right? It's obvious. But you may have thousands of different flows through your application. So you pick a few and you do it manually. With automation, you can write a single automated test, set it up in such a way that you just data drive it. So you have a matrix of data, and you can actually automate, by automating once, in the same time it would have taken a person to do this, you can actually go through hundreds, if not thousands of flows through a particular flow. And it's also important that you know that matrix, and you know the risks involved with that matrix. So you have all of this data, you have all of these paths through your code. Okay, what is the most important? So if we're talking thousands, then you can probably run it in an automated fashion depending on your application. If you have millions, which in a complex app is not that unheard of, you're going to need to know what are those critical paths, how likely are we to hit them, and then test for those, right? It's going to save you time, it's going to keep you sane, and it drives home that point that when you're automating, you automate with a scalpel. So we're not looking to run millions of tests, right? Because somebody's going to have to comb through all of those results. What we're looking for is a focused effort that automation, can handle. abstraction is important. So when we think about automation, we should think about abstraction in the same way we think about abstraction when we're coding and developing our applications. So we don't write one-off functions. We don't write one-off automated functions. We don't hard code if-else statements for every possible Android version in the past. Instead, we have abstractions to help us deal with those. And that concept is very important when we're looking at automation as well. So when we're looking at configuring the Wi-Fi network, or we're looking at configuring some other SDK type parameter, we should think about it in a way that we write a function that abstracts that beneath our abstraction. So when we are automating, we're calling this function that sets the Wi-Fi or whatever. And underneath the covers, it will do the branching. We're not doing the branching everywhere in our code. It's important, though, not to obsess about this. So people will get into this mode that we need to write really, really beautiful tests that will be cross-platform, for instance. So we're not only writing tests that run on Android and every version of Android, but it also will run on iOS and the multiple versions of iOS. At some point, you just have to take a step back and say, OK, that might be a goal for later, but we don't have to do that today, right? So don't let it suck up too much of your time. So I want to talk a little bit about the tools and frameworks that are available. Some of them I'll go into a little bit of detail about specific tools, but this list is not going to be exhaustive. And I think anybody with Google can go and look at tutorials on how to use these various tools and comparisons and so on. First of all, we have the tool that's called a recorder. So a recorder is pretty cool. It allows us to record actions on our application without writing any code. So it's fast. We're up and running really quickly. So typically we install a recorder. We run our app in an emulator of some sort or on a real device. We click through it. It records the paths. It generates a script. And now we can play it back. It's really cool in theory. And it means that also that non-developers can test. So if we're looking at a QA team that's not writing code, it allows them to create tests. Now, the downside to a recorder is that they oftentimes produce really fragile code. That code is usually full of stuff that's not really related to the flow that we're looking to automate. It's just stuff that the recorder happened to pick up, and it doesn't discriminate against what it's picking up. So it creates difficult to maintain scripts. And the last piece is that non-developers can create tests. So not only is this a pro, it can also be a con, especially because it sets up the expectation that non-developers can create tests. But if it's generating code and that code needs to be maintained, then we have non-developers maintaining code. So you're going to end up with developers either way, any way you look at it. So it's important to keep that in mind. The best practice, I would say, is to treat the recorder as a really fancy spy. So record your flows through an application, especially if you're doing black box testing. So if you're not the one actually developing the application and you simply have the app and you're tasked with testing it, this can be really handy in figuring out, OK, what really happens in the UI or in what kind of events are firing when I do this activity, right? And then you use that as a framework for building your own automation, but you're still writing code. You're not depending on a recorder to build everything. The exerciser monkey, I will just go over this really quickly. If you're not familiar with it, you should be. It's basically free automation. It just does stress testing. It's not smart at all, hence the name monkey. But it simply hits it with random events, and it's great for finding ANRs and those types of errors. I highly recommend using it. It's super, super easy. And it is a form of automation. OK, so let's talk about a few of the frameworks that are available. So we have the Android testing framework, which if you're developing, you're probably familiar with it. If you're not writing JUnit tests, then you probably know that you should be. But it's JUnit, it's Java. It provides instrumentation hooks so that we can access Android-specific functionality, which is great. I wouldn't say it's a downside that it provides only very basic functionality. I think it doesn't set out to do anything more than that. And it serves as the foundation for pretty much every framework that tests for Android on top of it. So you should definitely be using it. It's great for unit tests. And then, like I said, if you're familiar with this framework, as you get into the other frameworks, they're basically layers on top of this for the most part. So it'll be really handy. UI Automator. So UI Automator is also provided by Google. Again, JUnit and Java. It extends the testing framework. with UI selectors and manipulators. So it allows us to do things, unlike with instrumentation, it allows us to actually find elements in our hierarchy, interact with them like a user, and so on. So it's way more powerful for testing actual functional flows through an application. It also, and this is really important because none of the other frameworks really allow us to do this, it allows us to control system dialogues and other system components. So with most of the frameworks, the way they're written and they operate, they're sort of contained to your application. So if a system prompt comes up, or if you need to set something in the settings, you simply don't have the permissions to do it. And so if one of those dialogues comes up, you're sort of stuck, unless you have some sort of harness on the outside that will back its way out. Or you simply don't test that using automation and you leave those tests to manual testers. But with UI Automator, it actually allows us to get around this. On the downside, we're talking 4.1 only, so unless you have the luxury of only supporting Jelly Bean and Up, which most everyone does not, the framework won't allow us to have the coverage that we probably want. One of the things that we've seen a lot of is that people will actually write automated tests in some of the other frameworks, and then some of those system dialogue type tests that we're talking about, they'll actually automate in this framework since it's the only one. So a little bit about Robolectric. If you're familiar with the JUnit and the instrumentation tests inside of that come with the Android SDK, you're probably familiar with Robolectric. So again, it sits on top of JUnit. It runs in the JVM, so it's super, super fast. We don't have all of the overhead of an emulator. It mocks Android functionality, so we're using shadow objects that will return, if we make a call to some part of the Android SDK, we won't get back a stub, right, or an error message saying that it's a stub. We'll actually get back data that we expect, even though it doesn't actually exist. So it allows us to do much more complex tests than simple instrumentation. Not everything is mocked, so this would be the only downside to it. But I think that downside is far outweighed by how fast and easy it is to get up and running with Robolectric. So you should definitely be using it. And it runs in the background. You can set it up so every time you make a build, you will kick off your tests and so on. It's definitely something you should be using. Robotium. So Robotium is a framework that allows you to, again, similar to UI Automator, grab UI elements using selectors, including web views, so you can use CSS selectors and so on. Allows you to grab those controls, interact with them like a user. So it enables UI testing on top of the normal JUnit instrumentation testing. It's limited to the app under test. So I mentioned this before with UI Automator. You can jump out of your application. With Robotium, you cannot. And depending on your application, this may or may not be an issue for you. I would recommend it for anybody who's familiar with JUnit and looking to actually test more complex flows through the UI. It also supports both emulators and real devices. So this is actually pretty powerful. Whereas, obviously, if you're running in the JVM, you're not testing on an emulator or a real device. Cucumber. So one of the most popular frameworks in the Cucumber world would be Calabash. It allows you to write human-readable tests. So essentially, we're talking about Gherkin on top of Ruby. So you will actually write tests that have human-readable language, like I wait, my app is launched, then I wait for the welcome screen, then I click this button, and then I take a screenshot, something like that, right? Fairly nice in theory. And it is cross-platform, so that's nice as well. And it allows people, anybody basically, to look at your automated tests and know exactly what's going on. So it can be pretty powerful from a business logic standpoint. And one of the key sort of components of Cucumber that people always talk about is behavior-driven design. So the idea that it might not even be you as a developer or you as an automator writing the tests. Somebody else is writing those tests, and then you're filling in the back end. I would say that is something that you should be really careful of. I don't know how it really plays out in practice, right? Where you have somebody writing automated tests in this language, and then you're filling in the back. It simply doesn't work. I'd say far more often, this is a great way to get up and running with automation really quickly. It's built-in steps allow you to do basic flows through an application, probably way quicker than any of the other frameworks. On the other hand, if you're doing any sort of complex activities, so it's not just walking through your application taking screenshots, but you want to make sure that when you do this thing that the network traffic looks like a certain way, or that your packet looks a certain way before it goes out the door, anything like that, you're going to start writing custom steps. And that's how Ruby talks, or that's how Cucumber looks at things, is they call them steps. You have a Ruby piece, and then that Ruby piece could even have a Java piece at some point. And so if you, as a developer, find yourself writing these custom pieces, you're not using the built-in steps anymore, it can become really tedious, because all of a sudden you're not just writing code like you would be if you were writing in, say, UI Automator or Robotium. You'll find yourself, not only do you have to write the low-level piece, you have to write the intermediary piece, and then you have to write the high-level piece in plain English. It stops scaling at some point. So another new player on the block is Appium. And Appium is, if you're from the Selenium world or you're from web testing, Appium will look super familiar because it implements the WebDriver API. So the other cool thing about Appium is that it supports many languages. So you can write your tests in Python, you can write them in Ruby, you can write them in any number of languages. And like the other sort of more UI style frameworks, they actually will let you run not just on emulators, but also on real devices. And it's cross-platform. On the downside, it implements WebDriver, and WebDriver makes a lot of sense when you're testing web. Some of those pieces sort of fall apart when you're looking at native applications. So there are components in that WebDriver API for, say, cookies. And cookies don't necessarily map one-to-one to an app developer. So not everything totally will make sense. On the other hand, if you're coming from the Selenium world, I think it will make perfect sense. And like I said, it's a great choice if you're coming from that world. So commercial frameworks. So in addition to, and I didn't mention this up front, but all of those tools I just went over, they're all open source, freely available. They have very large communities behind them. But there are also commercial frameworks. The plus side of a commercial framework is that they have really good support. So typically you're paying a company a license fee, and in exchange you have some sort of training and all of these other components that go along with a commercial piece of software. You also get added features and integration. So if you're in a large company with large teams, you typically have very set tool, you have a tool set in place, you have bug management software, and you have source control, and you have all these components that have to work together. And these usually come out of the box with all of these integrations already in place. Also, longevity. So we just went over a bunch of different frameworks. I mean, we've not been developing mobile apps for that long, but the tool set has been evolving very, very rapidly since the onset, right? So tools have come and gone. That list was by no means exhaustive. So there is something to be said about longevity. The bad side of this, though, is that we're talking about proprietary tools, and proprietary tools mean lock-in. Not only are we going to get locked in, it's also going to mean that hiring people for these positions is going to be slightly more difficult because they're not necessarily using open languages or open platforms. They're often heavy and difficult to maintain. I wouldn't say always the case, but oftentimes because they have all those added features and they're sort of geared towards an enterprise customer, they have tons and tons of bells and whistles attached, which you probably will only use a fraction of. And the last piece is they cost money, right? Which, depending on your company, may or may not be an issue. I'd say for some teams, this definitely makes a lot of sense. But I mean, just know what you're getting into, right? That you are locking yourself into a technology. You're going to have a team probably come and do training, and get you up and running. It's not going to be something that you just download real quick, and a day later you can go and show off. Okay, we have some automated tests. It's a little bit more investment up front. One quick thing I want to talk about is Spoon. So Spoon is an open source project by the guys over at Square. And Spoon actually lets you run your app on your devices locally that you have hosted, and you run instrumentation tests. And in addition, they have a screenshot library that you can use. And then out pops a report. So it's super handy for running things in parallel because most of the frameworks that I just went over, if not all of them, are designed to run a test against a device. If you plug in multiple devices, you would find yourself writing your own harness, and they've already done this for you. And it's free and it's open source. And if you're writing instrumentation, there's no reason not to use Spoon, I would say. So after we've gone through all of those various tools, when choosing, what should we ask ourselves? How do we decide which of those tools is going to be best for us, or for our team? So first of all, and some of these questions look very familiar to, like what are we automating, or like what are we going to automate? For selecting a tool, what are we testing, right? So if we're testing just simple unit type tests, right, then I think it's pretty obvious. If we're testing way more complex UI type tests or flows, or we're actually going, then we're going to look at something like Cucumber or something like UI Automator or Robotium. If we're going to test really, really low-level stuff in our application, all the way to the high-level stuff, so we're actually doing some sort of integration testing, we're going to look at something like Robotium probably. What are our automation goals? And this ties directly into the next one. So who will write the automated tests? So if we have a QA team and they're tasked with automating the tests, what is their skill set? Are they going to write code? I would highly recommend that if you're taking on automation, again, that this is a software project and they should. But if not, then maybe something like Cucumber actually makes a lot of sense, right? It allows at least the large portion of the team that doesn't write code can still write tests. And maybe you have one or two resources that are writing the backend automation, but they have to be developers. And then before we finish and we go into Q&A, I will just give a quick slide about what AppThwack does, the company that I work for. So I have no skin in the game when it comes to which tools, or anything like that. I would say that I'm way more interested in people running automated tests. And from from my company standpoint, I want you to run them on our platform. But honestly, as an Android user, I would rather have you just automating and testing as much as possible anyway. So my experience is the one that I expect, and it's also the one that you expect to have with your application. So what AppThwack, what we do is we have a lab with about close to 300 Android and iOS devices wired up for automated tests. So all of the frameworks that we talked about today, including some others that we didn't, you simply upload your test and your application into our platform, either through our web application or through a Jenkins plugin or through Gradle and Android Studio, and so on. Our system will then run it on the devices you've selected, and these are real physical devices and carrier branded and so on. And then we deliver a report in just a few minutes, and that report has screenshots and performance data, high-level results, and it finds patterns and so on. So if you're writing automated tests, I would love to see your automated tests in your application coming through a system like ours. Thanks.